Hello students, welcome back to my channel. Today we will be discussing another algorithm which is merging. So merging is a concept which is used in many of the other algorithms as well, especially in merge sort we will be using this merging concept. So this is going to be a prerequisite to know what is merging in order to learn merge sort. So let us go ahead and see what is merging. So merging is the process of combining two or more sorted lists of data into a single sorted list. Now remember, it can be a sorted list as well as an unsorted list, but here we will be concentrating more on a sorted lists. So when I talk about lists, here we are talking about the collection of elements and it has to be in a sorted order. If we have two sorted lists, for example, I have 2, 3, 5 is one list. I have 10, 11 and 13 another sorted list. If I'm merging this and then creating another list, a single list, then this is called as merging. So this is a merged list, and here we have used two lists and combined them and created a single list. This is nothing but merging. So what is the logic behind this? In order to perform a merging of two lists is what we are going to learn today. So let us go ahead and see the problem statement first. So the problem statement tells us that merge two arrays of integers both with their elements in ascending order into a single ordered array. All right. So here we have used the term lists sometimes and we have used the terms arrays, but basically you should understand that merging is nothing but combining two list or two collection of elements, two or more it can be. So here we are talking about two arrays, hence it is a two-way merge what we are going to talk. Okay, two-way merge. So when I tell two-way merge, it is nothing but I'm going to be using two lists or arrays. And I'm going to create a single list that is called as a two-way merge. So this is the problem statement. So let us see one example here. As you can see, I have array 1 and array 2, and these are the elements. Now, what exactly is the output we are expecting when I perform a merge operation on these two arrays? So as you can see that in these two arrays, the smallest element, the first one is 4. So in my resultant array, I should have 4 first. The next smallest element is 5. So I should have 5 next. Next is 7. Then we have 8 in both the sides. So fine, we can write any one of them. And then we have 9. So this should be my output. So input is two arrays which are in ascending order, and then I should get an output of a single array which should also be in an ascending order. So what could be the logic for this? So what we are going to do is I'm going to take a counter I for this, and also I'm going to take a counter j for this. Okay, so I have array 1, array 2. So let me name this array as A and let me name this array as B. And then the resultant array is going to be C, where I'm going to store all the elements. Now what I will do is I will take the very first element, that is if my index I am counting it from 0. So this is 0, 1 and 2. And of course this is also going to be 0, 1, 2, 3, 4, 5, etc. Okay. Now first I will take the first two elements of both the arrays. So I will take array of 5 and I'm going to compare it with the array of 0 with the B of 0. So this is nothing but 5 and this is nothing but 4. Now I will compare whether this is greater or less. So whichever is less, that I'm going to store it in my resultant array, and I will increment the counter of only that whose value I have stored in the result. So in this case, we have stored 4. Hence, what I'm going to do is increment the counter for j. Also, I should have a counter here in order to say that, for example, in order to store the value in C of 0, let me take it as k. K is also going to be initially 0. I is also going to be initially 0, as well as j is also going to be initially 0. Now, when I compared A of I with A of j, I found that, B of j, I found that B of j is smaller. Hence, I am going to say that C of k is equals to whichever the lesser value, which in our case is B of j. Hence, that value is stored. Once I store that value, I'm going to simply increment the j value because we have taken the value from here. Also, I'm going to mandatorily increase the k value because, of course, the next element I want to store it in the next position. Once again, now what I will do is I will compare the I value we have not incremented. Remember, because I want to compare this element with the next element. So I'm going to compare 5 with 7. Now, in this case, we found that A of I is the smaller. So what I'm going to do, I'm going to store the value of A of I in K, C of K, which is nothing but 5. So the moment I copy this value, now I will increment the counter of that array whose value we have stored in the resultant, which in our case, it is nothing but I value. I value I'm going to increase, J value is going to remain same, and K value is going to be incremented. Next, what I'm going to do, once again, I will compare A of I with A of J. Here I'm comparing 8 and 7. What is going to happen is 7 is lesser. Hence, I'm going to store the value of B of J, which is nothing but 7, and increment the J value to the next position, as well as increment the K value to the next position. Once again, compare A of I, that is 8 with 8. Here we are finding that both of them are equal, so we can copy any one of them. Suppose I'm copying from A of I. So 8 I'm going to store here, increment the I value as well as increment the K value. Next, compare A of I with B of J. Here in this case, the smaller value of B of J. Hence, we are going to copy the value of B of J and increment the J value as well as increment the K value over here. Now compare. Now, of course, we need to put a condition that if the size of the array here, if I'm talking about it is n, the moment j crosses the value of n, we are going to stop the algorithm. And what we can do is we can check if a also has crossed its last value. In our case, it has not crossed. So whatever the remaining values are there, we can simply copy it into our resultant array. So this is what the basic logic of the array merge. Okay, so in this case, this is nothing but two-way merge. Remember this, students. Okay, this is a two-way merge because we are going to be using two arrays. Similarly, I can have three-way merge. Now, how can I do that? Let me take an example. If my first array has the values 5, 8, 9. Let me write vertically. This is array 1. Let me take array 2. It has 4, 7, 8. Okay. And I have a third value, which is, let me take 1, 3, and 12. Now, how does this work? Once again, I'm going to have a values here, for example, I, J, and K. I, J, K. And what I'm going to do is I'm going to compare the first three elements. All right. So here I found that 1 is the smallest. So what my output array is going to get? Output array is going to get 1 as a first output, and then I will increment the counter from here. Next, I will be comparing these three elements. Remember, I'm going to increment this now. Now, once again, when I'm comparing 5, 4, 3, 3 is the smallest. Once again, 3 is going to be stored here. Next, once again, I'm going to compare 5, 4, and 12. But in this case, what is going to happen? 4 is the smallest. Okay, and then 4 is going to be the output. Next, what we are going to do is we are going to compare 5, 7, and 12. Okay, because as and when we are writing it in the output, we are going to increase the counter. So out of 5, 7, and 12, we know that the 5 is the smallest. So 5 is going to be stored in the output. Next, what we are going to compare, we are going to increment this and we are going to compare 5, 7, and 12. And when you compare 7 is the smallest, 7 is going to be stored here and so on. Okay, this is the three-way merge. Similarly, we can increase this number of arrays how much ever we want. Hence, in general, we will call it as M-way merge. So M-way merge is nothing but we will have M number of lists and we can compare in this way and simply merge it into a single array, which is also in a ascending order. So this is what the concept is behind the merge of two arrays. So in this case, it is a two-way merge. So let us quickly see the algorithm. So whatever we have discussed till now, this is written in algorithmic form. This is the basic thing where we will declare the variables m, n, I, j, and k. Remember, m and n is going to be the size of the arrays. I, n, j, and k, as we have seen, is going to be the counter, which is going to help us iterate through the three arrays. Read the number of elements, that is the value of m. Okay, m is nothing but the number of elements in A, and n is going to be the number of elements in B. And also we are going to declare the arrays which is going to be A of size M and B is of size N, and C, of course, is output, which is going to be addition. Merge, since we are merging, the size is going to be the addition of N plus 1. And then I'm going to read all the elements into the array A, and also I'm going to read all the elements into the array B. Also, we are going to set I, J, and K to 0, as we have seen in the previous example. All right. Now, this is nothing but a code. Whatever just now we wrote, just now we executed, it is written in the form of a code. Okay. So let me just take an example. A, let it be 2, 4, and 6, and B is nothing but 1, 5, and 8. All right. So this is my input arrays. As you can see, the M value is 3 and N value is also 3. All right. So initially what we are going to do is compare A of I and B of J, merge the smaller number into the array C. So that is what we are going to do, as I said. So initially our I is at 0, our J is at 0, and K is also at 0. K is nothing but it is going to be the counter for our result. And we know that the result is the size of the addition, that is 3 plus 3 is nothing but the 6. So this is our C. All right. So now, how am I going to the comparison? I'm checking if A of I is less than B of J. So A of I is nothing but 2. Is it less than B of J? In our case, no. Okay. So because it is not true, I'm directly going to come to the else part. Else part means that B of J is less than A of I. So when B of J is less, I'm going to store B of J in C of K, which is nothing but I'm going to store here 1 and then simply increment J as well as K. So J is going to come over here and K is going to be 1, which means now K is going to point over here. So once again, I'm going to compare. Okay, so this loop will go until this condition is true. That is, I should be less than M and J should be less than N. All right. So initially I is 0, this is 0, 1, 2, and J is also 0, 1, 2. So until it becomes less than, the moment it becomes equal to 3, we are going to exit from this loop. Now, once again, check, compare A of I and B of J, which is smaller. In our case, 2, A of I is smaller, hence I'm going to copy. As you can see, if A of I is less than B of J, then store A of I in C of K. So that is what I did. And after that, what I'm going to do is increment the I value as well as increment the K value. Once again, compare A of I and A of J. Here in this case, I is 1 and J is 1. Hence, I'm comparing 4 and 5. So when I'm comparing 4 and 5, I know that 4 is smaller. Once again, A of I is smaller. So I'm going to store 4 over here and increment the value of I. All right. Once again, compare 6 and 5, and we know that 5 is smaller, hence store 5 over here and increment the value of J as well as K. Remember, simultaneously, K is also incrementing. So this is 0, 1, 2, 3. Now it is in 4. Compare 6 and 8, and we know that 6 is smaller, hence I'm going to copy the value of 6 here. K value is going to get incremented, and I value is now 3. All right. Now, when I'm coming back and comparing, here it is an AND condition, which means both of them should be less than I and M, but this is failing here. I is becoming equal to M. Hence, we will get out of the loop. But remember, we still have 8 remaining here. So how do we take care of that? So for that, we have this. Copy the remaining element of either array A or array B into array C. So how am I comparing? I should check both the arrays, which one is lesser. So first I'm comparing while I is less than M. No, I is not less than M because we have completed with all the elements here. Hence this is false. So I'm going to come to the next while loop. So this is B. I'm going to check whether J is less than N. This should be N. J is less than N. Yes, J is less than N. It is not equal to N. Still we have an element here. J value is 2. Hence this is true. So what I'm going to do is C of K is equals to B of J. So C of K value is nothing but 5. Here I'm going to store the value of 8 and increment the J value. Now J value is going to become 3 and also increment the k value. Okay, and once again check whether j is still less than n, but in our case it has become equal to, hence this while loop also fails, hence I have completed this loop as well. So once we have completed all this, print the elements of array from 0 to c of m plus n minus 1, that is nothing but 0 to 5. So we are going to simply print the merged array into the output screen. All right. So this is a very simple algorithm. This is for merging. This concept I will be using in the next video as well, where we will learn about merge sort. So I hope this concept is clear. Thank you for watching. Keep learning.